Okay, today's session we are going to discuss about data pre-processing technique. The objective of data pre-processing technique to achieve maximum data quality before actually it get processed by the data mining algorithm, right? Some of the major tasks which is associated with the data pre-processing, namely data cleaning, data integration and data reduction, data transformation and data discretization. So these are the data mining tasks which actually we are going to discuss under the data pre-processing. So first one is the data quality. Why we need to pre-process the data? As I mentioned before, so any data mining or the prediction quality is purely depends on the data quality which you are feeding as a input to that process, right? So what are the measures available for data quality? So the first one, multi-dimensional view. So how to measure the data quality? Accuracy in terms of uh, whether the data is correct or wrong, or it is accurate or not. So first of all, only the accurate data you need to give as a input for the data mining process. And then the completeness of the data. Partial data are not going to give you the quality mining or the prediction, right? So the data which is not recorded, sometime the column which is empty or blank spaces is not going to give you the expected outcome because of that data is not recorded or unavailable. So you are always need to have the complete data before you are actually feeding as a input for any data mining application. And then the data consistency. So some modified but some not. So there is a difference in the data, right? So data consistency also one of the measure need to be considered for the data quality. And the timeliness. So any recent data, if you are want to analyze, or the history of the past data you wanted to analyze. So based on the time, you are going to update that data. And believability, how trustable the data are correct. You need to check whether it is the actual data or it is the manipulated data. How you can trust that data, whether the data provided on that particular input is correct or wrong. So everything also verified before you are actually applying the data mining algorithm. And interpretability, how easily the data can be understood. So anyone, if want to verify the data, they are still able to understand what are the different data which is part of that process. It should not be too complicated, and it should not understandable by only the specific people. So in such a way, you need to prepare the data before you are applying any data mining algorithm. So all these measures are going to provide you the quality data for the data mining algorithms. So completeness, believability, then interpretability. So major task, as I mentioned before you are applying any data mining algorithm, you need to prepare the data. The preparation given in the form of pre-processing technique. Some of the task which is involved in the process of data pre-processing is listed out here. The first one is the data cleaning. What is a data cleaning? Fill in missing values. So whatever the values you are identifying, if there is no value in that particular column or the row, then you need to fill. So first and foremost job is fill the missing values, and smooth noisy data, and identify or remove outliers. Suppose you are taking the data in the range of 1 to 10, then the entry uh, beyond 10, suppose there is a 12 or 13, right? So it must be need to avoided, because you need to remove all those outliers. So any data which is falling under beyond that range, it will be considered as a outlier. And resolve the inconsistency among the data. So only consistent data will be considered as a um, quality input for any pre-processing step. So first you need to clean the data in the form of filling the missing value and removing any noisy data. So that process is called as the smoothing the data. Identify or remove the data which is fall uh, out of that range, called as the outliers, and then resolve the inconsistency issues in the data. So the next step is data integration. As I mentioned before, the data which you wanted to mine is actually gathered from multiple data sources. The sources generating the data are going to be integrated. It can be any transactional databases or multimedia database or any data warehouse. So you are going to integrate all the data which is collected from the multiple sources, and it can be viewed in the form of multi-dimensional data cube. So after collecting the data from the multiple database, you need to prepare a data cubes. So the data cubes are going to provide you the multidimensional view of data. So what is exactly the multidimensional view? So what is the, every data is going to have a multiple dimension, that is the relationship among the other data. So how it is going to be part of the different table, right? And we have also collecting the multiple files from the different sources. So everything need to be grouped. So it can be in the form of data cube or files or data warehouse or multiple databases. So all need to be integrated, and you must create a unified format, because the data what you are collecting from the multiple sources are not in the same format. So now you need to create a unified format so that you can able to apply any data mining algorithm over that data. And the next step is data reduction. We have dimensionality reduction, and numerosity reduction, and data compression. So the last one is very familiar, data compression, reducing the size of the actual data without losing any content. So there are two types in that, lossy and lossless compression. So always it is expected that without any loss of data, you need to reduce the data size. The actual content need to be retained, but still the size of the data is going to be reduced, right? And dimensionality reduction, just now I mentioned that the data may have multiple dimensions. So how you are going to group aggregate all the data and its related dimensionality, right? So this is what the data reduction part. And data transformation and data discretization is, you are going to fit into within some range. Actually you are doing some normalization process, right? So how to perform the data normalization, and how to create some concept hierarchy, how the data is going to grouped under the different category, different classes. So that is the concept of normalization. So students, am I audible?
Yes, sir.
Yeah. So data cleaning, data integration, and data reduction. And finally, you have data transformation and data discretization. Under the data transformation, data normalization, and generation of concept hierarchy. Now, we will discuss one by one task. First one is the data cleaning process. So, if you take any data in the real world, it is dirty, which means a lot of potential incorrect data you can find. So that incorrect data, because of the instrumental fault or human error. Sometimes it may be the computer error or the transmission error. So anyhow, you can find some incorrect data that need to be cleaned, right? So as we discussed in the previous slide, first thing you need to remove the incomplete data or the partial data. So technically lacking attribute values, you wanted to remove the data which is lacking attribute values and lacking certain attributes of interest and containing only aggregate data. So these are the different cases you can identify under the incomplete data. For an example, if you take occupation is equal to blank space, so that is a missing data, right? So it is not specified what is the occupation of that particular person. And the data contains some noisy and outliers error values also. For an example, if you take salary is equal to minus 10, this is not logically correct because it is a negative value. So logically there is no negative value assigned for any salary, right? So containing noisy data and there is an error, and if any data can fall under the out of the range, that will be considered as a outlier. So all these data need to be clean in terms of data smoothing technique. So noisy data also need to be removed, and inconsistent data. For an example, you take age is equal to 42. If you take the date of birth is 3/7/2010 given in this example, so if you wanted to calculate the age of this person according to the date of birth, this is not a correct value, right? And certain cases the rating was given in the form of numerical values 1 2 3, but the people who are actually entered the data may entered it wrong, like A B C category. So you need to remove all this inconsistent data as well as the duplicate records. So this is the one more type under the data cleaning process. And some intentional values discussed: missing data. January 1st as everyone's birthday. This is one example. Intentionally some values are manipulated or given wrong, so those data also you need to clean before you are actually moving to the next pre-processing step. So incomplete or missing data. So the data is not always available. Example, many tuples have no recorded value for several attributes, such as customer income in sales data. So this this is very much essential for the purchase history, but actually you will not able to find the customer income under the sales data. So this type of data is not always available. So missing data may be because of equipment malfunction, malicious issues which is related to that equipment, and inconsistent with other recorded data. Maybe it's deleted, and data not entered due to misunderstanding. So these are the some of the possible cases for the missing data. So data not entered due to misunderstanding, and sometimes it is not recorded due to the malfunction in the equipment, and certain data may not be considered important at the time of the entry. Later you feel like you need to have that data, but it is not actually collected. Not registered history or changes of the data. So every time when you are updating some data, it need to be recorded. So missing data may need to be inferred. And how to handle the missing data. So whatever the class label is missing, you can just ignore those tuple, right? It is not going to provide any sufficient data for the classification, not effective when the percentage of missing values per attributes varies considerably. So if you have more missing values in your data set, then the quality of prediction is also going to be very low, right? So it is better and it is always recommended to remove all those data, the data which is not going to have any class label, and fill in the missing values manually. If in case you are able to fill the data, the missing value, you have to fill the data and then you can apply the algorithm, right? So instead of just giving as a blank space, leaving it as a blank space, you can fill the data. If you know or you can able to calculate that value, then manually you can fill the data. So that is one more question also. If you are unable to calculate that value, sometime it may be infeasible, right? So fill it automatically with some global constant. So something like unknown, a new class you can create, and you can provide the values for that, or sometime you can take attribute mean value. So based on that mean value you can fill the missing data. So attribute mean for all the samples belongs to the same class, right? So this is also recommended for fill the data, that is the missing data, automatically. So one thing, you can fill the missing value manually, or you can automate by introducing the global constant or taking the attribute mean, right? So the most probable value, sometimes you feel like this is what the most probable value. So based on the inference, something like a Bayesian formula or the decision tree, these are the some of the algorithm we are going to discuss in the upcoming slide, the data mining algorithm. So based on that, you can fill the missing value, right? And the next category of data is noisy data. Noise, it's a random error or the variance in the measured variable. So it is because of some incorrect attribute values. So what are the different cases of incorrect attribute values? So faulty data collection instruments. While you are collecting the data, the instrument itself will generate the faulty data. And data entry problems. So the people who actually entering the data may done some mistake. Because of that, you may get the noisy data. And data transmission problems and technology limitation. Certain cases you will not able to generate the data beyond that limitation because of the technology limitation. Inconsistency in naming convention, right? And other data problem which require data cleaning. So it has duplicate records, incomplete data, and inconsistent data. So due to the instrument fault, or due to the human error, or due to the technology limitation, or inconsistency in the naming convention, so anything could be the reason for incorrect attribute values, which is part of the noisy data. The other problem which is listed out here which is actually required for the data cleaning, involves duplicate records, incomplete data, and inconsistent data. So how to handle noisy data, like how to handle the missing data, how to handle the noisy data. So we have some techniques like binning. So binning is the process which is going to first sort the data and partition into equal chunks or bins. So what is the equal frequency? Let's say divided by 2. Each data length, maybe the 8-bit data or 16-bit data likewise. So equal chunks we are going to create. So first you need to sort the data and you need to partition the data by equal chunks or the bins. So then one can smooth bin by calculating the mean value, or smooth the bin by calculating the median and its boundaries. So these are the some of the option which is available for smoothing the noisy data under the binning technique. So you can take mean value or calculate the median, or based on the boundaries also you can um, smooth the data, noisy data, by using the binning technique. But first, initially you need to sort the data and then do the equal partition and then perform this smoothing activity. Then the second technique is regression. So regression, how you are going to smooth the noisy data? You are going to smooth the noisy data by fitting the data into regression function. So you are going to fit the actual data into the regression function. So in that way also you can reduce the noise exist in the data. And one more technique is the clustering. So clustering is a grouping of similar objects together, right? So within some boundary. So you can, if you manage to detect and remove the outliers, the data which is fall out of that range, right? So for an example, you have taken the range of 1 to 10, there's a data fall under 50, 70, then the other data which is close to the range, then these are called as the outlier, that 50, 70, everything. So 1, 2, 3, 4, 5, everything will be part of that cluster within the range of 10. Right. So detecting and removing the outliers is a one more technique to handle the noisy data. And combined computer and human inspection. So sometime the combination of manual and the computer based verification also will give you the better result. What is that? Detect suspicious values. So you may manually verify, or computer based verification also possible. Check, is there any suspicious values which is part of your data set, and remove the outliers, whatever the outliers is possible. So these are the some of the techniques that is recommended for the how to handle the noisy data. So one thing is the binning, another one is regression, the clustering, and combined technique for verifying the noisy data by combining manual and the computer based inspection over the data. Next, data discrepancy detection. So data cleaning as a process, one of the process under the data mining technique. So data cleaning is a process which is part of the pre-processing technique. So what type of a data discrepancy you can identify? So sometimes use a metadata. So metadata, if you wanted to define the metadata, it's a data about the data. So example, you can classify the data based on its domain, range, dependency, and the distribution. So these are the some of the other factors which is actually available for finding any faulty data or any data discrepancy detection. So whether it is fall under the domain or under the range, or there is a proper dependency and distribution, equal distribution. So likewise you can verify, right, and check field overloading. Certain case the data with the values are going to be overloaded. That also you can check the field overloading and check uniqueness value and consecutive rule and the null rule. For an example, the previous class I was mentioned, the primary key must be always unique. So if you take any database, the primary key value must be unique, something like a register number under the student table. So the register number is a unique value, right? So check its uniqueness because you don't want to have any duplicate data, right? And check its consecutive nature and the null value also. So some of the commercial tools also used to check all these kind of data discrepancy. Something given here like data scrubbing is used to detect the errors and make the corrections based on the domain knowledge. So once you are a knowledgeable person in particular subject, so you can able to correct some errors in the document, right? Subject knowledge. So likewise, data scrubbing is a one commercial tool which is used to check the errors involved in that data by identifying any spelling mistake or any wrong data which is entered under that domain, and it can do some correction. And one more type of a commercial tool is data auditing. So from the name itself you can understand it is going to verify the data and its completeness, right? It's going to verify the quality of the data, if there is any data violation, or it is going to verify the correlation and clustering to find out the outliers. So these are the some of the current commercial tools used to detect any data discrepancy. The next one is data migration and integration. So why we need to migrate the data? Because we want to collect the data from the multiple source. That data need to be stored in one unified structure. After you are creating some unified structure only, you can able to retrieve the data in a proper way to apply the data mining techniques. So the data need to be migrated from the multiple source to the unified structure. So allow the transformation to be specified. So very important keyword ETL, which is related to any data mining tool: extraction, transformation, and loading. So there is something called ETL layer, which is part of the database management system. So always extract the data from the multiple data source, transform or fit into some range, right, and then load the data for the analysis or extract the data for the analysis. So extraction from multiple source and transforming into some range and loading it for the processing, right? So the allow the user to specify the transformation through graphical user interface. And integration of the two process, it involve iterative and interactive process. So certain case it is iterative and certain case it is the interactive model like Potter wheels. So the next one, so far we were used to discuss about data cleaning part. So how to handle incomplete, noisy data and inconsistent data, and what are the different techniques involved in the process of data cleaning. Now we are moving into data integration. So far, any doubt, student? Data cleaning. Am I audible?
No problem, sir.
Okay, thank you. So data integration, as per the previous discussion, combining the data from the multiple sources into coherent store. So you need to create a unified structure where you are going to store the data which is collected from the multiple source, right? So the schema integration is also need to be performed because the data which you are collecting from the multiple sources not in the same format, right? The schema integration also need to be performed, like the table, if you wanted to join the table from the customer uh, A table and the customer B, right? And if you wanted to integrate as a whole the customer detail, right? So integrate the metadata from the different source. That is also part of the schema integration. And one more thing is the entity. So can anyone tell me what is an entity? What is an entity and attribute? Any answer? It is already given in the slide itself. So identify real world entities from the multiple data source, right? So you are actually collecting the data from the multiple source, and that you need to identify the entities, right? And detect and resolve the data value conflicts. So what are the conflicts may occur in the process of data integration? In some real world entity, the attribute values from the different sources are different. That's what in simple terms I have mentioned, that the data which you are collecting from the multiple sources may involve multiple data format. You need to provide a unified structure, and the possible reason for this different representation. Sometimes it's a text or the image or the audio or the video file, or it's a categorical value, right? So different data formats are there and different scale. So some value data value range between 1 to 10, and something will go 1 to 100, right? The range will also differ. Example, metric versus British units. So these are the some of the possible reason for uh, the data value conflicts, which is related to the data which you are collecting from multiple sources. And how to handle data redundancy, duplicate data. So how to detect and identify the duplication. So redundant data occur often when integration of multiple databases. Maybe the same data exists in multiple database or in the multiple tables, right? So actually you don't want to create a redundant data which is part of the data mining process, right? So object identification and derivable data. So the same attribute or the object may have different names in a different database. So name may differ, but the values can be same, right? Same attribute or object may have a different name in the different database. And one more thing is the derivable data. One attribute may be derived attribute in another table. So based on the income table, you can derive a annual revenue or purchase history, the total turnover you can derive from that. So age can be derived from the date of birth, something like that. So some data can be derivable, and same attribute can have a different names in different databases. So these are the some of the reason for the data redundancy while you are integrating the data from multiple data stores. And a redundant attribute may be able to detected by correlation analysis or covariance analysis. So always it is recommended that the careful integration of data from the multiple data sources help you to avoid data redundancy or any data inconsistency to improve the mining speed, because you wanted to improve the performance and also you wanted to retain the quality, right? So both can be achieved with the help of careful integration of data from the multiple data source and removing or reducing the data redundancy and inconsistency in it, right? So this is the way you can improve the performance of any data mining algorithm as well as the quality. So one of the analysis model used under the nominal data is correlation analysis. So there is a chi-square test for performing correlation analysis under the nominal data. You can apply some chi-square test. The formula is given here. X square is equal to summation of observed minus expected the whole square divided by expected. So what is actually observed minus expected, the subtraction of observed and expected, the difference is whole square divided by expected. So the larger of x square value, the more likely the variables are related. So the cells that contribute most of this x square values, those actual count is very different from the expected count. Just simply finding the difference from what is actually expected, what is actually observed. So you maybe expect the output will be 10, but you get the output 5, right? So the difference is 5. So what is the cells that contribute the most of this x square value in your data set? you need to identify those cells, which means the exact instance, the columns which going to make a greater impact on the outcome, right? So larger the x square values, it is more likely the variables are related. So the correlation does not imply any causality. The number of hospital and the number of car theft in a city are correlated. So you can see that both are casually linked to the third variable, nothing but the population. Nowhere there is a relationship between the number of hospital and number of theft in a city. But still, you can correlate each other by introducing the third variable, the total number of population, right? So you can see that chi-square calculation, one example is given here. So the people who like science fiction and people does not like science fiction, and in the column you have they will play the chess and they will not play the chess. What is the total number of people, the sum of the row, right? So there are two different category, and their nature of playing chess, whether they will like to play chess or not. People who like science fiction more will play the chess more, right? Comparatively, according to this example, it is given 250 for play chess and not play chess is 200 out of 360, right? So people does not like science fiction, play chess 50 here, not play chess is 1000. The number is got increased. So automatically it is, you can conclude that the people does not like science fiction will not play chess games, right? So it is going to add and provide the sum of the people who will play the chess 300 as a whole, combination of these two, and not play the chess 1200, and finally the 1500. So this type of a chi-square calculation is computed based on the, just now I showed one formula, observed minus expected the whole square divided by expected, the summation of all the values. So the number in the parentheses are expected count calculated. So within the bracket, the numbers given within the brackets are the expected counts. So it is expected that only 90 will play, but here the number got increased. 360 here, but the number is 200 in this case. It is reduced. Once again, you see 210 in this case, the number got reduced 50, and 850 in this case, the given value is 1000. So observed minus expected the whole square divided by expected. So what is observed in the first row, first column? 250 is observed, the actual outcome, minus what is expected, 90 divided by 90, plus summation of all the values. So what is expected in the second row of the first column, right? So expected 210, what is observed, 50. So likewise, if you add all together and finally you will get 507.93. So how to conclude this example, it shows that the people who like science fiction and play chess game are correlated in the group, right? So in an average of 507.93. So the people like science fiction will play the chess. So that is what correlated are you can observe from this outcome. And for the numeric data, so far the previous example is based on the nominal data. For the numeric data, you can perform the correlation analysis based on the computation of correlation coefficient. So here one technique named Pearson product moment coefficient. So you need to calculate the correlation coefficient for the given numeric data based on this formula which is given. So here the n is the number of tuples. A bar and B bar are the respective mean values of A and B. So summation of AI minus A bar and BI minus B bar divided by n minus 1 into sigma A and sigma B. Right. So you can also represent this formula like this. So what is sigma A and sigma B? These are the respective standard deviation of A and B. So you need to compute mean value of A and B for getting the value for A bar and B bar, and also you need to compute the standard deviation of A and B, right? And then perform the summation of AI into BI, that is the sum of AB, which is you are going to apply the AB cross product, right? So what is the condition here? The relation, the correlation coefficient of A comma B, which is greater than 0, A and B are positively correlated, which means that A values increases as B value increases. That is a higher correlation or the strong correlation between A and B. That is what called as the positive correlation. If or A comma B is equal to 0, then independent. And if R AB is less than 0, negatively correlated. So positively A values increase, B values also get increased. That is a strong correlation between the A and B. If you take a negative correlation, the value of correlation coefficient is less than 0. So based on this computation, you can conclude whether it is the positive correlation or the negative correlation or independent. So but you need to compute the coefficient, that is the correlation coefficient value. So now how to evaluate this correlation in terms of visualization. So here there is an example for visually evaluating the correlation among the given value. So here you can see some scatter plots which is showing the similarity from -1 to +1, right? So the similarity of values which is ranging from -1 to +1. So here you can see that -1 to +1, the similarity of the value. It is the third value is -10 and it is 0, and it is the positive correlation moving towards the positive values, right? So from the negative to the positive. So similarity from -1 to +1. So positive correlation. So correlation viewed as a linear relationship. So correlation measures the linear relationship between the objects. To compute the correlation, we have some standardize the data object A and B and then take their dot product. So here the computation formula is given here. Correlation of A comma B. You are taking the standardized data object A comma B, then the dot product of A comma B will give you the correlation value. So A dash AK, first of all you need to understand how to calculate A dash K. So A dash K is equal to AK minus mean value of A divided by standard deviation of that object A. Similarly for B, right? BK minus the mean value of the object B divided by standard deviation of the object B. So how to compute the correlation? Correlation of A comma B is the dot product of A dash and the B dash. So the correlation measure the linear relationship between the objects, and the next one is the covariance. So based on the numeric data, how to compute the covariance of the two object A and B. Students, am I audible? Yes or no?
Yes,
Yes,
sir.
sir.
Students? Yeah. So how to
Audible,
calculate
sir.
the covariance? Yeah, fine. Thank you. Covariance, the category is a numerical value. So the covariance is similar to correlation. So covariance of A comma B is equal to, so A minus A bar and B minus B bar. So you can also represent it summation of the I value ranges from 1 to n, A minus A bar and BA minus B bar divided by n. So you need to understand what is n. N is the number of tuples, and A bar and B bar are the respective mean, as like the previous case. And the expected values are A and B. Sigma A and sigma B are always will give you the standard deviation. So the values which you wanted to compute under the correlation coefficient, the covariance of A comma B divided by sigma A and sigma B. So here also, like the previous correlation analysis, you can find three different cases: positive covariance, negative covariance, and independence. So independence, always covariance of A comma B is equal to 0, but the converse is not true. So if the covariance correlation coefficient is greater than 0, then A and B both are tend to be larger than the expected values. So if it is a negative covariance, the covariance of the coefficient value is less than 0, then A is larger than its expected value, and B is likely to be smaller than its expected value. That is what the exact representation of the different cases. The coefficient value greater than 0 means A and B both are tend to be the larger than the expected values. But in the case of negative covariance, A is larger than its expected value, but B is likely to be smaller than its expected value. Some pairs of random variables may have the covariance of 0, but they are not independent. And some of the additional assumptions also given: the data follow multivariate normal distribution, and the covariance of 0 imply the independence. So already we discussed all these things. So this is the one more type of a correlation analysis based on the numerical data. So here real-time example is given for the covariance. So you wanted to compute covariance of A comma B. So it can be simplified in a computation as covariance of A comma B is equal to A dot B minus A B bar. Right. Suppose you take two stocks A and B having the values in 1 week. So the set of values are given here: 2 comma 5, 3 comma 8, 5 comma 10, 4 comma 11, and 6 comma 14. So what may be the query? If the stocks are affected by the same industry trends, will their prices rise or fall together? So once again, the stocks are affected by the same industry trends, will whether the price will get rise or fall together. So how to calculate the covariance for the given two stocks A and B? So you can separately calculate E of A and E of B by adding all the A values divided by total number of tuples, here 5, right? 20 divided by 5, it will give you 4. Similarly B, so adding all the B value divided by 5, so 9.6. Now you can compute the covariance of A comma B by taking the dot product of A into B minus A bar and B bar. What you have computed is the A bar and B bar, 4 and then 9.6. So now the cross product of, sorry, dot product of this particular stocks: 2 into 5, 3 into 8, plus 5 into 10, 4 into 11. So if you compute all the values, then the result will be covariance of A comma B is equal to 4. So what is the conclusion? It is positive value, so greater than 0. A and B both tend to be larger than the expected values as per the previous definition, right? Now the result is 4. So A and B rise together because it's a positive. So it is expected to have the price increases both A and B stock together, since covariance of A comma B is greater than 0. What is the result you got? 4. Right? So according to the result, it is the positive covariance, right? So both A and B stock prices will increase together. That is what the conclusion. Any doubts, students, so far? Covariance, correlation analysis, chi-square analysis. So everything related to how to handle the redundancy, the data integration part, right? How to calculate the correlation coefficient and covariance. Any doubts, students?
No, sir.
Data cleaning and data integration. Okay, fine. So then I'll move to the next pre-processing stage, data reduction. So you are going to reduce its dimensionality. So obtain a reduced representation of data set that is much smaller in volume but yet to produce the same analytical result. So you are going to reduce the size, the data size, the volume of the data, but still it produces the same analytical result. That is the way you need to perform the data reduction. So why we need to go for data reduction? If you take any database or data warehouse, we store the data in terms of terabytes to petabytes. So it is always too difficult to analyze this complex data, and it will also take a very long time to run the code and complete the data set. Because of that, you need to reduce the volume of data, or you need to select the data which you are going to do some analysis process from the whole data, right? So this is the way you can perform the data reduction and need for the data reduction, because in the whole data, if you wanted to run some algorithm, then it will take very long time and it will not complete as soon what you are expecting, right? And data reduction strategies. So some of the strategies are listed out here: dimensionality reduction, numerosity reduction, and data compression, right? So what is dimensionality reduction? Example, remove unimportant attributes. So how to remove the unimportant attributes? Some of the attributes you may feel it is not going to make an impact over the analysis, so you can directly remove those unimportant attribute from the data set. So under the dimensionality reduction, you can identify wavelet transforms, principal component analysis, and feature subset selection and feature creation. So these are the some of the techniques under the dimensionality reduction. And one more strategy is numerosity reduction. Simply call it, you can call data reduction. So some of the techniques involved under this type of reduction is regression and log linear models. Histograms, you can represent the data in the form of histograms, clusters, and you can perform some sampling. And data cube aggregation. In the initial discussion, we used to discuss about how to generate the data or create the data cube, how to perform various operation over the data cube. One of the operation is data cube aggregation. So that is also can be used under this type of a reduction. And data compression is a one more strategy followed under the data reduction. So how to remove the data which you feel less important for the analysis process, how to remove or reduce the data site. Still, it managed to produce the same analytical results. So first strategy is dimensionality reduction. Cause of dimensionality: when the dimensionality increases, data become increasingly sparse. The density and the distance between the points, which is critical to the clustering and outliers analysis, and it is become less meaningful. So these are the some of the points you need to take into the consideration for the dimensionality reduction. The possible combination of subspaces will grow exponentially. So if you don't perform any strategy, the kind of a dimensionality reduction which you are applying over the data, that is a possible combination of subspaces will grow exponentially. So what exactly the dimensionality reduction? So it is going to avoid the curves which involved, or it is listed out in the previous case related to the data dimensionality. It will eliminate the irrelevant feature and reduce the noise. That is what expected for any quality input data set, right? So irrelevant features, the features, and reduce the noise, reduce the time and space required in data mining. Of course, you can reduce the time, the execution time, and the storage space required in the data mining, because you reduce the size of the data. So once you reduce the size, you can reduce the space as well as the execution time. And also you can view the outcome in a simplified manner. So you can see here, allow easier visualization. If you want to plot the result of the execution, the outcomes, if you wanted to plot in terms of a graph, then it is very easy to visualize the outcome with a limited data set, right? So these are the some of the advantages related to the dimensionality reduction. And what are the exact techniques under the dimensionality reduction? Wavelet transform, principal component analysis, supervised and non-linear techniques. Example, feature selection. So the first one, wavelet transform, right? So mapping the data to the new space. So you are going to apply some Fourier transformation and wavelet transformation. So you can see in this example, in this case, they are given two sine waves and two sine waves plus some noise data. Noise signals are represented in the second graph. And this is the frequency variation. The third graph will give you the clear picture about how the data frequency is drastically vary across the given range of data values, right? So these are the different type of mapping. Wavelet